welcome you to the session on what is supply chain science. I am Professor Jitesh Thakkar, Professor Logistics and Supply Chain Management and Dean Academics at Gati Shakti Vishwavidyalaya, India's first and only university in transportation and logistics sector. It's a central university established by Ministry of Railways, Government of India. University is located in the city Vadodara, Gujarat. You can see the textbook Mastering Logistics and Supply Chain Management 100 Insights to Optimize Your Operations, published by me and Professor S.G. Deshmukh, IIT Delhi. You can also refer this textbook to understand the various dimensions of supply chain management and supply chain science. You can see my profile. I am broadly operating in the domain of logistics and supply chain management, service operations management, project management, rail operations, and you can see the publications I have made in the reputed journals like International Journal of Production Economics, International Journal of Operations and Production Management, and Computers and Industrial Engineering, Transportation Research Part E, and so on. And the 5 textbooks: Structural Equation Modeling, Project Management, Multi-Criteria Decision Making, Mastering Logistics and SCM, and Service Analytics and Management are published by me. You can also scan this QR code and visit my YouTube channel named as Professor Dr. Jitesh Thakkar, and you can explore the various intellectual content benefiting students, faculty, and industry professionals. You can also refer my published research by scanning the QR code of Google Scholar on right-hand side, and you can connect with me on LinkedIn. Gati Shakti Vishwavidyalaya is a central university, India's first and only university in transportation and logistics sector, and it has a very unique mandate to contribute in the domain of transportation and logistics with a focus on all 3 dimensions: technology, that is infrastructure; management, that is services; and policy, that is regulation. University has entered into various domestic and international level collaborations with the prestigious organizations like St. Petersburg State Transport University, Russia; Monash University, Australia; JTTRI, Lucini RS SPA, L&T, Nippon Koi, Jacobs, Alstom Airbus, and so on. And university operates with a unique vision, innovation-led, industry-driven university. Gati Shakti Vishwavidyalaya University offers programs for both regular students and working professionals. The programs for regular students includes BTech program in different disciplines with a focus on railways and transportation, and MBA Logistics and Supply Chain Management, MBA Ports and Shipping Logistics. And for working professional, the variety of program with a focus on transportation sector like MTech in Intelligent Transport System, MTech in Railway Engineering, MTech in Bridge and Tunnel Engineering, MBA in Multimodal Transportation, MBA in Metro Rail Management are offered. You can also see the detailed program curriculums at the suggested web link and understand the unique value propositions of the academic programs offered by Gati Shakti Vishwavidyalaya. Let us look at the broad premise of supply chain science and typically what it intends to address. So typically as a part of this talk, we will see that what is the unique importance of supply chain science, which is a data-driven approach, deploys the scientific principles and quantitative methods to optimize the various decisions in the supply chain. So it involves mathematical modeling like network design models, linear programming, integer programming, inventory optimization. It involves data analytics and machine learning. Typically, it is with a very critical role of data analytics and machine learning in identifying the patterns. So today we are living in the VUCA world, and the demand uncertainty, the business uncertainties are significantly high. And in this situation, many a times my linear models, traditional models of forecasting and prediction do not work. And I really have to reveal the pattern in the data, which is quite complex and causal in nature. And that is something where data analytics and machine learning helps me. Inventory. So inventory optimization, determining optimal stock levels. The goal is to minimize the holding cost and ensuring the high service level. That is another domain which falls into the supply chain science. Stochastic modeling. This has very critical role to play typically when I am dealing with the situation where my demand and lead time both are highly uncertain. And this inherent uncertainty in supply chain, fluctuating demand, unpredicted lead time can really be captured using the stochastic models. So if I look at the supply chain science, then it basically develops the scientific mindset with a focus to address four important objectives. Number one is the cost reduction. So, how I can identify the inefficiencies in the supply chain and reduce the cost. Number two, improved service level. If I have better forecasting, I can match my inventories well with the demand and avoid the stockouts and provide the right product to the right customer at the right time, leading to higher customer satisfaction. Enhance resilience. Modeling various scenarios helps prepare for disruption, making the supply chain more robust. And fourth, most important, is achieving the overall competitive advantage. So, data driven decisions provide significant edge over competitors relying on intuition alone. So let us see, when we talk about the supply chain science, what is the premise? So the focus is on five most important dimensions and their trade-offs. Number one is the cost. Number two is the quality. Number three is the speed, responsiveness. Number four is the services. And number five is the flexibility. When you talk about the supply chain competitiveness, it is basically these five dimensions and the trade-off which we set between and among them decides the competitiveness of my supply chain, design of my supply chain, structure of my supply chain, and the resilience in the business. So let's look at a couple of interesting trade-offs among these five factors and how the various organizations across the world they handle these trade-offs efficiently. So when we talk about the quality versus cost, certainly in today's world you cannot say that you offer the product or service at the lesser cost and customer would be happy to accept the poor quality. Absolutely not. But yes, there is a trade-off between quality and cost, and let us try to see it through an example. So if we see the Ford models, then Ford Focus compared to the Jaguar XKR, these are two important models, and people they would regard the Ford Focus as competition for the Jaguar XKR. And what is this competition? So the reason is that although all of the dimensions which we discussed, five dimensions, cost, flexibility, responsiveness, that is the speed, quality, all these dimensions matter to customers for both the cars, let it be Ford Focus or Jaguar XKR. Buyers of the Focus are concerned primarily with the cost, while the buyers of the Jaguar are concerned primarily with the quality as they perceived it. So quality customers, they expect as they perceive. So if we see this typical expectations of the market, then the logistics system to support the two cars should be designed with different set of priorities in mind. Even though they are manufactured by the same company, the priorities in deciding the right structure of the logistics is different. For instance, while the Jaguar system might be able to afford to have quality technicians inspecting quality, single pass quality at the source, methods are almost mandatory for the focus in order for it to compete in its price range. So I would design my logistics for the Ford Focus and the Jaguar XKR totally differently, keeping the customer expectations and the trade-off of quality versus cost in mind. Where would I spend and how I can accommodate the expectations of my customer through appropriate priority setting in the design of logistics network really matters, and hence the supply chain science has a very, very critical role to play. Let us look at the second trade-off, that is speed versus cost. MRO business is a very big business, typically in aviation, manufacturing, and many other sectors. So WW Granger is the MRO, maintenance, repair, and operating suppliers business. And through catalog and online sales, Granger offers hundreds of thousands of products, ranging from maybe cleaning supplies to power tools to safety equipments and so on. But all these products are made by the supplies. Granger in reality does not manufacture anything. So when you look at the customer, a customer could choose to purchase any of the Granger's product directly from a supplier at a lower unit cost. Then the question comes, why a customer would go to WW Granger when they can have the same product available directly from the supplier? Let us look at the trade-off. So, given this condition, as I mentioned, why would customer go to Granger? So the reason is that Granger can ship small orders with short lead times, while the suppliers require longer lead time and the bulk purchase. Granger's business strategy is to offer speed, responsiveness is there, and in exchange of price premiums. So they are charging premium prices for the same product which otherwise you can have from the direct supplier for the responsiveness and the speed. They support this strategy with the logistics system that inventories product in warehouses and focuses on efficient order fulfillment. In contrast, if you look at then the logistics systems of the suppliers concentrate on production efficiency, they will go for mass production, they will look for the bulk orders, bulk purchase, and therefore tend to make and ship products in large batches. Let us look at the another important trade-off and interesting trade-off, that is service versus cost. Let us see this through an example. Peapod.com advertises itself as an online grocery store. You must have referred to this particular business. And when this business was originated, Peapod functioned by picking orders from local grocery stores and delivering those orders directly to the customers' homes. More recently, Peapod has developed its own system of warehouses from which deliveries are directly made. By offering customers the opportunities to shop online and forego visiting the supermarket, Peapod's business strategy is based primarily on service. Customers, those who are willing to shop for bargains and transport their own groceries, can almost certainly achieve lower cost. So, to achieve this service advantage over traditional grocery stores, Peapod requires an entirely different logistics system centered around internet ordering, home delivery, opposed to stocking and sale of merchandise in retail outlets. So through this example, you can appreciate that when you go to the grocery shop or a retail shop, and when you go for the businesses like peapod.com, what additional advantage you can have in terms of service versus cost. The another important trade-off is flexibility versus cost. So let us look at the IBM and in what way they tried to offer flexibility versus cost. So before they outsourced it, IBM manufactured PCBs, printed circuit boards in Austin, Texas. Although they made thousands of different PCBs, a high fraction of their sales dollar only came from, say, sales of the final end items. So this type of demand distribution is typically called as Pareto distribution, and it is absolutely very common in industry. So because all the products required similar processes, it would have been feasible to manufacture all the PCBs at a single plant, and you can have the advantage of economies of scale, and you can reduce your overheads per unit cost. Let us see what IBM did. So IBM divided the facility into two entirely separate operations, one to produce low volume prototype boards and one to produce high volume boards. To high volume plant made a use of heavy utilized specialized equipment to achieve the cost efficiency, while the low volume plant employed flexible equipment subject to frequent changeovers. So these two environments are totally different, and that made sense to keep them physically separate. And this sort of focused factory strategy is well suited to a variety of production environment with widely varying products. So putting together, we have seen the trade-off among 5 different focus factors and why data analytics, the supply chain science, and the economics, that putting together really helps. So why supply chain science matters? Let us look at through some more examples and critical questions. Let us say you have implemented some lean manufacturing practices and reduced your in-process inventories. What should be your next step? You have achieved some remarkable improvement in the inventories, WIP, and what should be next step? How do you identify the portion of your system that offers the greatest leverage? You are managing, let us say, a service operation, and since services cannot be inventoried, it is absolutely intangible in nature. You are wondering whether any of the underlying ideas of lean manufacturing apply to you. How can you decide what can be adapted? The third critical question that draws our attention towards the importance of supply chain science: you are managing a multi-product manufacturing system. You have quite diverse product portfolio. Now the question is, which of your products should be made to order and which should be made to stock? Push and pull. What should you consider in controlling stock levels of both components and finished goods? You have problems getting on-time deliveries from your suppliers. How much of an impact does this have on your bottom line? What are your best options for improving the situations? So there are many such questions. For example, you feel that better supply chain management could be a source of competitive advantage. How do you identify the improvements that would make the most effective? And once you identify them, how do you justify them to your upper management? So all these questions will draw your attention to one important fact, that today you cannot do supply chain management on intuition basis when you are living in the VUCA world, when you are dealing with the fluctuating demand and highly uncertain lead time and global supply chain. The tariff considerations are significantly high. You really have to go by the data analysis, scientific approach, data driven approach, and that is where supply chain science comes into play. So what is supply chain science? It's a discipline that uses mathematical models, algorithms, data analysis to understand, design, and optimize complex supply chain system. And typically, this goes beyond traditional management and logistics by applying just rigorous quantitative approach to solve real world problems. So instead of relying on intuitions or experience, and you try committing the mistakes in the uncertain environment, you try to address couple of critical questions in supply chain through strong data analysis. How much inventory should we hold? Where should we locate our warehouses? It's a fixed cost. It will have a significant burden if that additional warehouse is not generating a revenue for you by providing higher level of services and attracting greater market share. What is the most efficient delivery route? How can we predict demand with greater accuracy? So you can see that there are very, very critical domains and areas, questions, which simply we cannot address by repeating the same old practices or the SOP kind of uh, adapt SOP kind of practices. You have to really get into the data analysis. You really have to make use of operations research, statistics, economics, and computer science to build a framework for making better, more informed decisions. So, why supply chain science is important? This session typically focuses around supply chain science, its importance, and why should we get deeper into this supply chain science really to make our supply chain competitive. So number one is cost reduction and efficiency. So by using optimized models, you can identify most effective ways to manage your operations. This can include minimizing transportation costs, reducing inventory, holding cost, eliminating waste, which directly impacts your bottom line and competitiveness in the supply chain. Second is risk management and resilience. So you just see recent global events like COVID-19, pandemic, and many other natural calamities. This has highlighted the fragile nature of supply chains, fragility of supply chain, and supply chain science helps in identifying mitigating the risk by modeling potential disruptions such as natural disaster or geopolitical conflicts, and this can improve the resilience of your supply chain. Number three, improve decision making. So as we referred that it helps you to focus on the trade-offs among five focus areas in the supply chain with data-driven decision making, and this sets even the basis to convince your top management for any kind of supply chain adoption, modification, or investment. Number four is the enhance customer service. So optimize supply chain. You look at the Ola, Uber, network optimization, planning models. When this scientific approach is adopted, then you can manage your demand forecast, well, streamline your logistics, and companies can reduce lead times, minimize stockouts, provide a superior customer experience, and this translates into increased customer satisfaction and loyalty. The fifth important dimension is competitive advantage. So certainly today we say that one supply chain is competitive other uh, over other supply chain, and that is where you have to see the appropriate trade-off among cost, service, flexibility, and the quality. So lower prices due to reduced cost is the advantage, faster delivery because of network optimization, responsiveness to market. All these are unique advantages you can experience through supply chain science. Sustainability, yes, this is one of the very, very important dimensions, and we try to minimize the wastages across supply chain, its environmental impact. So mathematical models can be used to optimize supply chains for environmental sustainability. This can include minimizing carbon emissions, from transportation, reducing waste, and choosing more sustainable sourcing options. There are key algorithms used in the supply chain science. For example, for demand forecasting, time series analysis, ARIMA, exponential smoothing. Now, in today's era of AI/ML, machine learning models, regression neural networks, which can reveal the complex relationships and patterns among the data points, are highly used for predicting the demand. Similarly, inventory management, you have economic order quantity model, which is the base model, and lot many other variations of EOQ are available to make it more suitable for the real life situation. Stochastic inventory model like use vendor model, this can help you to accommodate the uncertain demand. Logistics and transportation, traveling salesperson, even you have stochastic traveling salesperson problem, vehicle routing problem, route optimization, network design algorithms, supply chain network design, you have the choices like location allocation models for warehouses and facilities, which can give you the best trade-off in terms of the cost and service level, optimizing sourcing and distribution network. There are various advanced and modern topics which we can explore as a part of supply chain science, and certainly leverage these tools and techniques for enhancing the resilience, responsiveness, and the efficiency of our supply chain. So one of them is simulation. So we can use the Monte Carlo simulation model. You can even model the continuous variables and the events using the system dynamics model, which accommodates the causality. Optimization heuristics, you can look at the approximate algorithms for complex problems. Evolutionary algorithms are another domain where genetic algorithm, simulated handling, particle swarm optimization, and many other taboo search you can use. Blockchain in supply chain. So typically, how decentralized ledger can improve the transparency and traceability. And this technology is becoming very popular to see that across supply chain, global supply chain, a unique platform can cater to the transparency and ease of transferring the information and improving visibility. AI and machine learning in practice. So you can look at some of the real world examples of how AI is transforming. Typically, you can see the Amazon and many other businesses, how they are using AI, and from autonomous vehicles to predictive maintenance. So Gati Shakti Vishwavidyalaya is India's first and only university in transportation and logistics sector, and it is offering the programs at all the levels: undergraduate, postgraduate, PhD, executive training, to enable the nation's aspiration to reduce its logistics costs from present 14% to 8 to 9%. University is driven executing various programs with a unique vision, innovation-led, industry-driven university. Thank you very much for your interest in understanding what is supply chain science.